Let's take a look at a problem that deals with balancing equations, molar masses, and stoichiometry. So the question reads, when ammonia reacts with fluorine, fluorine is a diatomic element, so we'll write in F2 because it's a diatomic element. The products are dinitrogen tetrafluoride and hydrogen fluoride. So A says write out the balanced chemical equation. So let's start by putting down ammonia, which is a gas, plus fluorine, which again is a diatomic element that exists as a gas at room temperature, produces dinitrogen tetrafluoride. So that's it's also called tetrafluorohydrazine. Anyhow, that's neither here nor there. But that's N2F4, put gas, and then we also get hydrogen fluoride gas. There we go. So if we have to balance this equation, we have 1 nitrogen in ammonia, we have 2 in dinitrogen tetrafluoride, so we'll put a 2 here. Then what else? We have 6 hydrogens on the left, and we only have 1 on the right, so we're going to have to put a 6 here. Then if I tally up all the fluorines, I have 6 plus 4 gives me a total of 10. So what times 2 is going to give me 10? The answer is 5. So there we go. Now I have a balanced equation. Okay, part A done. Almost finished. So B says, how many moles of each reactant are needed or required to produce 4 moles of hydrogen fluoride? So what I'm going to have to use to determine how many moles of each reactant, the ammonia and fluorine, are going to produce 4 moles of HF, I'll have to use my balanced equation. So if I started out with my 4.00 moles of HF, if I want to know how many moles of ammonia I'm going to need, I can just go to my balanced equation and get the conversion factor from there. And I see in my balanced equation that for every 6 moles of HF, I have 2 moles of ammonia. Okay, so if I look at my dimensional analysis, you see that moles of HF and moles of HF cancel out, and I'm left over with the number of moles of ammonia that I would need. So that would be 1.33 moles of ammonia. There we go. Similarly, for fluorine, I do the exact same exercise. So I put 4.00 moles of HF, and I again go back to my balanced equation. I have 6 moles of HF, and for every 6 moles of HF, I use up 5 moles of fluorine from my balanced equation. Again, the units cancel out, and this time I get 3.33 moles of fluorine that I would need. There you go. So that covers there's part B. So then in C it says how many grams of fluorine are needed to react with 25.5 grams of ammonia. So I'm just going to move this up a little bit here. So how many grams of fluorine are required to react with 25.5 grams of ammonia? So now we're going to have to calculate the molar masses of ammonia, of fluorine, and of dinitrogen tetrafluoride, and probably, actually we don't need HF for this question. But anyhow, I've already gone ahead and done that, so by now you should already know how to go to the periodic table and add up atomic masses to get molecular weights for these molecules. So I'm going to start with my 25.5 grams of ammonia. And again, let's read the question. See, it says, how many grams of fluorine are required or needed to react with 25.5 grams of ammonia? So if I have 25.5 grams of ammonia, what's the minimum amount of fluorine I would need to react, to consume all that ammonia? So again, I'm going to go back to my balanced equation, but the first thing I'm going to have to do is convert the grams of ammonia into moles of ammonia. So again, I calculated the molar mass of ammonia, which is 17.03 grams of ammonia in every 1 mole of ammonia. Hope I don't run out of space here. Then I go back to my balanced equation, and I see that for every 2 moles of ammonia, I use up 5 moles of fluorine. Then the question is asking how many grams of fluorine. So I go over to my periodic table. I calculate the mass of 1 mole of F2, which is 38.00 grams of F2. And look, if I examine the units, you can see that grams of ammonia are going to cancel out, the moles of ammonia are going to cancel out, then moles of fluorine will cancel out, and I'm left over with grams of fluorine like that. So in this case, I get 142 grams of, I'll just write it down here, of fluorine, like that. Now if we do the exact same exercise, but this time it's asking us how many grams of dinitrogen tetrafluoride can be produced when 3.40 grams of ammonia react. So let me just put this down here. So D. So I know that I've got 3.40 grams of ammonia, and it's asking me how many grams of dinitrogen tetrafluoride can be produced. But before I can get to my balanced equation, the first thing I need to do is to convert this number of grams of ammonia to moles of ammonia. So I'm going to use the same conversion factor that I used for the previous part. So 17.03 grams of ammonia and 1 mole of ammonia. Good. And then I look at my balanced equation and I see that for every 2 moles of ammonia, I have 1 mole of dinitrogen tetrafluoride. Okay, there we go. And then I calculated the molar mass of 1 mole of dinitrogen tetrafluoride. It is 104.01 grams of N2F4. And again, if I go back to my dimensional analysis and I examine it, I can see that grams of ammonia are going to cancel out. The number of moles of ammonia are going to cancel out. Here's the conversion factor from my balanced equation. So moles of dinitrogen tetrafluoride are going to cancel out, and I'm left over with grams of dinitrogen tetrafluoride. In this case, I get 10.4 grams. 10.4 grams of dinitrogen tetrafluoride. So there's the answer for D, and I'll put the answer for C in a box. So hopefully that gives you some help on molar mass and calculations using stoichiometry. So before you can approach any of these problems, you have to have a balanced equation. If you don't have a balanced equation, like we have in A, you will never end up with the correct answers. And then after that, it's just a matter of doing dimensional analysis and getting all of your units to cancel out in order to get the answer that you're looking for in the end. Anyway, I hope this is helpful, and I'll put some other videos up that deal with limiting reactants in the near future.